Hi, I'm an old guy and I do maths. And today we're going to look at how we graph y equals tan 2x minus pi on 3. The domain of x I've set as pi on 6 to 7 pi on 6. Now this is effectively a distance of 1 pi. Pi on 6 plus 6 pi on 6 gives us 7 pi on 6. The period of this function is given to us by pi on n. So the period is pi on 2. And one of the things that I find really helps me when I'm setting out a tangent graph is to figure out where the asymptotes go, or figure out where one asymptote goes, and then I can work a period in either direction and just keep going for as long as I need to. So this is a two-step process in this case because of what we have here in the brackets. Now, the first thing I'm going to do is I'm going to deal with this 2 here. This is n, and so our period is pi on 2. Now, normally an ordinary tangent graph would have a period of 1 pi, which means that we would start off with an asymptote at pi on 2, 90 degrees. If you don't understand why there is an asymptote at 90 degrees for a tangent graph, go back and have a look at how tangents are constructed. They are opposite over adjacent. At 90 degrees, the adjacent is 0, so you just get nonsense. Y equals tan x, the asymptote would be at pi on 2. If we have the period, that means that the asymptote moves to pi on 4. And so this is our first move, a dilation away from the y-axis of 1/2. That's the language of this. Now, what's the next thing we do? Because there is more to do. Well, I find it useful to rewrite as y equals tan 2 into x minus pi on 6. And this is my next step here. I'm going to translate my asymptote, my starting point for this, pi on 6 along the x-axis. I'm going to move it along here. It's a dilation away from the y-axis, if that's how you want to put it. Anyway, it's this translation here. We move from pi on 4, a distance of pi on 6. Now, what does that do? Well, it's pi on 4 plus pi on 6, which gives us 5 pi on 12. 6 fours are 24. 4 plus 6 gives us 10 pi on 24, which gives us 5 pi on 12. 5 pi on 12 is where the first asymptote on this graph will be, and I can then work with that to get what the rest of the graph looks like. And here is what the rest of the graph looks like. There's a fair bit of working here, so I'll just explain this. We'll start with my asymptote, as discovered, 5 pi on 12. Now, again, thinking about a normal tangent graph, my starting point on a normal tangent graph would be here at 0, but everything has been moved pi on 6 to the right. So that's where this tangent graph starts. It's actually the lower limit of the domain of x as well, and it is equal to 0. Now, Another way of thinking about this is starting from the asymptote, 5 pi on 12, and subtracting half of the period, which is pi on 4, which gives us 5 pi on 12 minus 3 pi on 12, which gives us 2 pi on 12, and pi on 6, our point here. That's one way of getting there. Of course, the easier way is to simply add pi on 6. Okay, so where does the next asymptote go? Well, the period is pi on 2, so 5 pi on 12 plus pi on 2 gives me 11 pi on 12. That's the next asymptote. By symmetry, this point here is 7 pi on 6. That is 1 pi away from pi on 6. You'll notice that if you add these up, you get the equivalent of 2 periods, one here, half here, and half here. So this is pi plus pi on 6, which gives me 7 pi on 6. And this is a symmetrical function, so this is reflected essentially to this. I can't think of a better way to describe it at the moment. Now, this curve here, which is what you would expect to see in a tangent function, has an asymptote, as I said, at 11 pi on 12 and 5 pi on 12. And its midpoint is here at 2 pi on 3. And here's how I get to 2 pi on 3. It's not actually as laborious as it looks. It's pretty easy to figure out. But here goes. I have pi on 6 here plus the period, pi on 2, which is pi on 6 plus 3 pi on 6, which gives me 4 pi on 6, which gives me 2 pi on 3. There are other ways of doing it. You can take 5 pi on 12, and you can add half the period, which is pi on 4, just as we did here with subtraction. Anyway, this, in the end, is what the graph of y equals tan 2x minus pi on 3 looks like between pi on 6 and 7 pi on 6. I hope you found that useful. It can be quite a bit to get your head around when it comes to doing these. But if you approach them in a sort of a logical and methodical fashion, you will get a result. And better still, you'll get the right result. Thanks very much for watching. Please remember to like and subscribe, and I'll see you next time. Bye.